Right now, I'd like to introduce Dr. Steve Levine, Chief Strategy Officer for Simulia, and he's going to take us on the journey of the living heart and provide for us the progress, remarkable progress of this project since it was announced in May. So, ladies and gentlemen, let's greet Dr. Steve Levine.
Here we go. Here we do. Hi, everyone. Thanks for taking the time today. I appreciate your flexibility in recognizing that we're going to get to this project a little bit sooner than planned. Great news for me, because I love talking about this project. I think you'll understand it a little bit better. You've heard a little bit about it over the last 2 days. We heard Bernard Charles talk a bit about it yesterday. He spoke beautifully about the inspiration, about how the project can bring life to the 3D Experience platform. What I'd like to do today is give you a little bit more of the background of why we did the project, how it came about, and more importantly, how we did it. Because how we did it is probably the most important element of the project itself, and why I believe that this can be a really transformational project for the company. So the Living Heart Project really grew out of the inspiration driven by Bernard himself. With this statement, when he redefined the purpose of Dassault Systèmes to go beyond just helping companies produce great products, but to really help understand how those products contribute to our life. How do we make the world better through the products we create? How do we improve the world? And really, can we understand and use our digital technology to improve life as we know it? So I'm a strategy guy, been leading the strategy for Simulia brand for about 9 years now. And so I thought long and hard about how we, as a simulation brand, can take our simulation technology that's been really powerful in helping aerospace companies and automotive companies to be able to produce products cheaper, faster, better, all the things they need to do. But could we actually help directly simulate life? Would that be possible? And so we asked ourselves, well, what if we provided this same simulation technology that we provide to aerospace engineers and automotive engineers and washing machine engineers, cell phone engineers? What if the medical profession had the same technology to be able to address the problems of human life? Could we really simulate something as profound as understanding the human heart, the source of life really in our bodies? Could we understand the physics, the electromechanics, the actual behavior, and predict how devices would interact, how we can improve those design? Can we test them, make them safer, more reliable before they ever get put in a human body? The way we do with cars, we would never put a human body in a car before we test it, but sadly we do have to put devices in human bodies before we can really test them virtually. And the limitations really get down to a question of technology. So for those people who know me, realize I'm a strategy guy. I don't think small, I think big. So when we thought about doing the human heart, they sort of said, well, that's a pretty big task. Maybe we should start with something smaller. And I kind of looked around and said, well, is there really a good reason to simulate the human heart? And so I showed a few of these statistics. So cardiovascular disease, first and foremost, it's the #1 cause of death worldwide. More people die of cardiovascular disease than anything else. 30% of deaths are due to this one single problem. Economically, it costs the US alone, according to the American Heart Association, almost $450 billion today in economic loss due to this. And that is projected to grow, if we continue on the current course, to $1 trillion in 15 years. So we're not winning this battle against the #1 cause of death. We have 2 million procedures performed worldwide that don't have the benefit of virtual testing before they ever do these procedures. The regulatory agencies in the US alone, this is information that maybe you really prefer not to know, but 95% of all the devices that are released to the public have never actually been tested in the human body before they're brought on the market. And there's good reason for that because it's really unsafe to put these products. It's challenging to find patients who are willing to take these new and novel products. And the cost of doing it in just 1 year would cost the FDA alone $3 billion just to run those tests, much less the cost to the manufacturers and the time. And the result is a stifling of innovation. Companies are risk averse to bring new innovations to market because they don't have a really good way of ensuring the reliability. So we decided to take on the challenge of addressing this really important societal problem with our technology. So the question is, how do you build a heart? So we decided to go back to the basics and said, okay, we've worked with cardiovascular companies before. We know a little bit about tissue mechanics. We know a lot about material properties, typically metals and plastics and things like that. But we have worked for the last 10 years to understand a little bit about tissue, and there are laboratories that'll do testing, and we can replicate those tests on the computer and get detailed material properties. But the heart is a little bit different. It doesn't just respond to forces, it actually generates force. So you stimulate that heart tissue with an electrical impulse, and it pushes the blood, the fluid out of the body. So now we needed a model for the tissue that could actually accept force and drive force. And that's a complicated physics problem, but that's what we do, take on complicated physics problems. And so we were able to do that, and then we constructed something that might not look much like a heart to you, but to us, this was pretty exciting because we took all those little building blocks and we built a little 4-chamber model of a heart, and each one of these chambers is actually beating due to stimulation. And internal to that, they're coupled the way a heart would be, feeling the pressure of the blood flow that a real heart would do. Of course, doesn't look much like a heart, but it gave us enough encouragement to roll up our sleeves and say, okay, let's see if we can go ahead and build a heart. And that's what we did. And about 12 months ago now, we took this basic model, applied it to a heart, and we revealed the very first heart simulation to the world that looked like this. So we got together a dozen or so experts from around the world who were cardiovascular specialists, people who had studied, who had done research, medical device companies. And we showed them our vision. We showed them what we were able to do. We gave them the opportunity for pretty much all of them, and I'm guessing for all of you, the first time to actually look inside a beating human heart, to understand what happens inside the heart, and the profound impact of being able to see the kinds of things that people were trying to study but never could actually see inside was really, you could almost call it breathtaking. I think many people found themselves transformed by what we could do, by taking this technology that really was developed for completely different application, but we reimagined what it could be, what it could do. And that created this new opportunity, and we were incredibly encouraged to be able to take this prototype to the next level. Of course, we knew going from prototype to a real human heart is not a small feat, and we couldn't do it alone. So we formulated a project that we called the Living Heart Project, wrote a mission statement. The goal was to, first and foremost, help and advance the development of safe and effective medical cardiovascular devices. Our premise was not to go off and reinvent the science that had been created over the last 20 years, but to bring them together, to use the power of the 3D Experience platform to unify the best of the best and to say, if we all work together, we can solve this important societal problem and translate all this good research into actually changing the way we address this important problem. So we had to go out and reach out to universities, researchers, practicing cardiologists, medical device companies, instrument manufacturers, the regulatory industries, and said, okay, we think we need all of you to come together and help. Turns out, that's not a small feat. The heart research, again, as you know, this is the biggest medical problem facing society. So there's a lot of work being done out there on this topic, but it's fragmented. It's in silos. Each group works on a different element of the problem. Some people look at the fiber orientation. The heart is very complex tissue. It's made up of layers and layers of fibers that are spiraling around in unique capabilities, and people are studying the detailed behavior. And others look at the electrical conductivity through the fiber network. And they all worked on a different piece and created their own model, and nobody could share any information because they worked in isolation and there was no collaboration. So we said, okay, let's all get together and try to standardize and work on a common platform using the 3D experience technology and to build a single heart that we could bring it to life, and then everybody could then use that same heart to advance their research and share information and work as a reference for the entire industry. And then we can apply some good engineering principles to a really tough scientific problem. And amazingly, we actually got people to do this. So when we launched the project, we announced it in May of this year, about 6 months ago. We had a dozen organizations sign on to help us bring this heart to life, to make it accurate and validate it against real performance of the heart, bringing together their expertise, whether it be electromechanics or device insertion or behavior or regulatory regulations, so that they could actually use this as a tool to submit and accelerate innovation and bring it to market. And with the help of that group of people, we were able to produce this version of the heart, which is actually completely electromechanically stimulated. It's the first heart, full 4-chamber heart based on commercially available, validated technology where you can study. You'll see in this representation in the middle, you see the typical simulation analyst view where they're looking at the mesh and they want to understand the detail and how we handle the thin elements and whatnot. On the left side, you see the mechanical representation, the stresses in the heart, which would be important if you have heart failure. You want to understand how your physician can help you with heart remodeling to help get the function back, or a valve or assist devices that will help your your chambers function normally. On the right, the exact same heart, you can study the electrical conductivity. So if you're having a problem like atrial fibrillation, where the conductivity goes awry and your heart starts to flutter and bad things can start to happen, we can study those behaviors now because we have the same technology across a single platform that everybody's working towards. So this is pretty profound, and it's based on commercial technology so that everyone can have access to it. It can be shared, it can be referenced. So to get this story out, it wasn't really easy. We knew we had to work on getting the physics right, but we also had to communicate how you could do this. And so we looked to our colleagues in other parts of the organization in a 3D experience platform, and we built these really amazing demonstrations. And you can actually see some of these. On the left, you can see a heart that we put in the cave in our headquarters in Paris and in Boston, where you can walk inside this human heart. And we heard yesterday someone talk about an immersive experience. Well, there's nothing more immersive than stepping inside a beating human heart with the muscle tissue moving around you and the heart and the sounds emerging. It's a really profound experience and insightful. It's not just a demo and you can see it, but when you get that up close to how something works, you understand its behavior. And again, really profound impact of those visualizations. We have, you can take a fly-through of the heart. And we built these portable holographic images of the heart. You can see here. In fact, we have one of these tablets here, and you can play with it yourself. It's a little personal device. I think I have a video here, where you can actually take the heart, and he's looking at this, and he's wearing 3D glasses, so he can see the heart in 3D. you can actually see what he's looking at. So he's now working on a beating heart floating in front of him, where he can now take that heart, investigate it. He's using a little slice plane. This is just an early demo, where you can actually cut the heart in half and look inside. We can look at in this case, the mechanical properties. So if this were your heart or my heart, a doctor could understand exactly where the weak parts are, so he could know what to do. Using this really cool technology, you could prototype surgeries where you can take the heart apart. And if there's a problem with your valve, you could look inside and the surgeon could take the valve and understand what's wrong with it, and then insert a device and then simulate it and determine will it actually improve the behavior or not. So this has been quite a journey for us. As you can see, we started only 12 months ago with a little cube of human tissue, muscle tissue to understand the fiber orientation, and we went through a series of evolutions where we demonstrated and we used the power of visualization to communicate our vision. And that vision was really to transform an entire industry by taking technology that we had validated for decades in other areas. For example, the fiber technology that we use to simulate the muscle tissue was really developed as part of our lightweighting initiatives that we worked with aerospace companies and automotive companies to look at carbon fibers. So we were able to take the representation, the physics representation that we have in our simulation technology designed to look at airplane wings and apply it to the human body just by transforming the material properties. Not a small task, but it demonstrated the power of having a uniform platform and how we could reimagine our business. So we now have moved past the model we announced with. It's actually, the heart model's now been validated to produce the right output, produces the right volume of blood is pumping, the right pressure volume, and that heart's now been released into beta test. So we've gone from concept to a product out in beta test in less than 12 months, really by using the power of collaboration, by bringing together these world experts and building on a mature platform. And it really demonstrates, we've talked a lot over the last few days about bringing together groups in multiple disciplines, but I think this is one of my most profound examples of what bringing together cardiologists, medical device company regulators, researchers, and saying, come on, let's go do this. And in 12 months, we've done what the industry hasn't been able to do in decades. And we now have over 30 members signed up. We launched just in May with 12. We now have over 30 members that have joined on to contribute to make this heart the definitive standard. And we've begun to look at the various applications we could have. One of the really exciting things that I was able to do, I'll show you this before, you've seen some of the visualization from our sister brand, 3DX site. So they kind of looked at our heart and said, yeah, that doesn't look like a heart to us. It's like a representation. So they took it and they made this heart. It's a little bit scary, but to you and me. But if you're a surgeon and you're trying to understand, and this is just to show you the difference in visualization, this is the exact same heart looking at just the electrical conductivity, cutting it open. So if you're a surgeon and you want to study what you're going to see when you go inside the body before you get in there, you want it to look like what you want to look like. You want to use all your senses to be able to recognize what you want. And then you can superimpose the physical behavior, the mechanical strains on something that looks like what it should look like. There are applications in education, so that if you're teaching cardiologists in medical school how a heart behaves, you want it to look like a real heart. Or you might want it to look a little less real, but have all the appropriate anatomical landmarks on it. And so we can do that with the right physics, but with a different visualization technology. So the power of unifying it is really impressive. So for those of you who want to learn a bit more, I invite you to go to our website, 3ds.com/heart. There's a bunch of videos. We've, as you can imagine, to bring together all these organizations worldwide, besides me getting on a plane and running around, we've done a lot to create, to capture our vision in these images, and some of them are really exciting. I invite you to the exposition. We've brought one of these tablets so you can play with the holographic heart. We actually have a portable cave here, so you can actually get inside the heart yourself if you're brave enough. And one of the other things that I'm not showing here, but if you go on this web page, one of the things you'll see is the very first story that we told. I produced an animated video that kind of captured the vision that we had for how I thought our technology could really transform this industry. And we told the story of a young lady who was about to go through a life-altering surgical procedure, and the story takes you through how we think our technology can help her through the process, help her surgeon, and how we believe we can really make a better world through that technology. And I got really positive response from that, but a lot of people asked me, well, why'd you choose to tell the story using a young girl? Surely the market for cardiovascular devices is something more like, this guy, middle-aged guy, probably hasn't taken good care of himself, and now he wants his doctor to patch him up. As you can see, I thought about that, and I thought about, well, we could tell his story, but instead I decided to tell this young lady's story. You can see it on the web page, and this was really the inspiration, because this young lady was actually inspired by this young lady. And this young lady, she had the great misfortune of being born with a heart unlike pretty much anyone else's. Her heart was born backwards. The left and right chambers are reversed. And if you were paying attention to any of the videos, you find out the heart's not symmetrical. You can't just swap the two. One side's designed to work under low pressure to the lungs, one under high pressure to the body. And if you swap them, some not so good things happen, and the electrical conductivity is supposed to go through the wall. Where are the nerve, where are the electrical fibers? All different. And so as a result, you can see here she's getting her second pacemaker at age 8, first one at age 2. But thanks to advances in medical technology, she's able to have a life. In fact, she's able to do things like normal activities, normal non-contact activities, like ice skating, because she has wires running through her body. Some not-so-normal activities, like singing the national anthem at baseball games, raising awareness for cardiac patients. And here she is getting her 4th pacemaker before the age of 20, and having to have the realization of having 3 broken wires in her body because there was really adequate testing for what those simple mechanical devices, not so simple devices, but mechanical nonetheless, what the stresses would be for her to have a normal life, and those wires will be in her body pretty much for the rest of her life. And this actually is that young lady today. So she's taken her experience and decided to dedicate her life to become a medical researcher, doing a dual degree, MD, PhD, studying neuroscience. Cardiology is a little too close to home for her, and she's trusting the rest of her colleagues in cardiology to allow her to have the opportunity to have a full life so that she can advance the knowledge of the brain so she can then help others while we do our best to help her. And if you've noticed, if you're paying close attention and you notice the name, you realize that this is actually my daughter. So I tell this story because it's really meaningful, but meaningful to me because when I think about the words we began, and the words of Bernard, harmonizing product, nature, and life, and why we do what we do, these are not just words to me. I think about my daughter and the thousands like her, that one day whose lives will be dependent on our technology really making a difference and harmonizing it. And that makes me really proud to be part of this industry. And I want to thank everyone for helping us and supporting us in our journey. Thank you. So for the last bit, we actually have a little bit of news that we're announcing today. Project has made great progress, and to assist me with the news, I'd like to invite our CEO, Bernard Charlez, up on the stage.
How are you?
Good, thank you.
I'm always moved when I listen to you. This is a family story because Dassault Systèmes is a family also. Not only you have an amazing story behind the motivation to make this possible, but as you know, one of my daughters is also pediatric cardiologist.
Yes.
So we have a lot of common multidisciplinary connection.
Strong children.
Yes. And today is a special day, not only because this reveal on this project is something that means something to us, and that shows that in the way we can contribute to the society is also with this big dream, harmonizing product into your own life, is going by pieces. As you know, Steve, we also work on oncology, which is a serious topic, cancer. We started in '99, but today we are announcing, thanks to you, your leadership, that the FDA, we are creating a partnership with FDA on building up, on providing to FDA on all the ecosystem. Those 30 plus are going to be over 100 top specialists who will use this really to make progress in this domain. So this is going to be a press release that is going to be issued on the wire today.
Yes.
And you are the first to learn about it. And I want to congratulate you in front of everyone for this amazing
thank you.
achievement.
And I want to thank you for your inspiration and support. Yes. Thank you.
This is what it takes to have strong beliefs and put teams together to make it happen. Thank you again, Steve.
Thank you.
Congratulations to you.